This is section 4.3 on right triangle trigonometry. So this is going to be somewhat of a review on what you learned about right triangle trig in geometry. So first starting off, we have 6 trig functions. So you're probably familiar with these 3: sine, cosine, and tangent. We also have what we call the reciprocal function. So when we flip sine over, we get what is called cosecant, which is 1 over sine, secant, which is 1 over cosine, and cotangent, which is 1 over tangent. So when you look down here, um, if you remember from geometry, we use SOHCAHTOA to help us remember the trig ratios. So if sine is going with the opposite side over the hypotenuse, if we look at cosecant, so we abbreviate that with CSC, that would be hypotenuse over opposite. So it's the flip, I like to call it, of sine. Same with cosine and secant. So cosine is the adjacent over the hypotenuse, whereas secant is the hypotenuse over the adjacent. And here we're talking about the different sides in a triangle. And then here we have tangent, which is opposite over adjacent, and then the cotangent is the flip, adjacent over opposite. So when we're thinking about opposite versus adjacent, first the hypotenuse, I like to always label my hypotenuse first because it's always whatever is directly across from my right angle. So whatever side is directly across from the right angle, that's always the hypotenuse. The adjacent and the opposite side depend on the angle we're looking at. So this right here, what we call theta, we use that to represent an angle. So if this is my angle theta down here, the opposite side would be the one across, and the adjacent is the one that touches that angle. So this is all the same as what you saw in geometry. Now we're just adding in these 3 new functions, and they are called the reciprocal functions because we are flipping sine, cosine, and tangent. So to evaluate these, it says use the triangle below to find the exact values of the 6 trig functions of theta. In order to do this, to find all 6, we need to have all 3 sides of the triangle. So our first step here is we're going to want to use the Pythagorean theorem to find the missing side. So if you forget what the Pythagorean theorem is, it says a squared plus b squared equals c squared. And C has to be the hypotenuse, so this is always C. It doesn't matter what number you put for A and B. So I put 3 as A and 4 as B, but if you did 4 as A and 3 as B, you would get the same answer. So when I plug in, I'm looking for C. I square my numbers, so I get 9 plus 16 equals C squared. When I add that together, I get 25 equals C squared. And then my last step is to take the square root of both sides, and we get C equals 5. So my hypotenuse is 5. And now I have all 3 sides of my triangle. So now that I have all 3 sides, my next step is to use the trig ratios to write out the 6 trig functions. So my first function, I like to always do it in the same order, do sine, cosine, tangent, and then do the reciprocal functions. So first, sine is always the opposite over the hypotenuse. So here we have the hypotenuse labeled. The opposite side would be 4, and then the adjacent side would be 3 to this angle because this side is next to the angle, and then here when we draw a line to the side that's across, that would be this side over here, 4. So opposite over hypotenuse, 4 over 5. Cosine is adjacent over hypotenuse, so that would be 3 over 5. Tangent is adjacent over or opposite over adjacent, so that's 4 over 3. And then we do the reciprocal. So cosecant, we flip sine. Secant, we flip cosine. And cotangent, we flip tangent. So I like to do it in this order and also set it up like this, these 3 on this side and the reciprocals on the other side. And that way you match up which ones you have to flip. So we are going to skip through this special right triangles part. I'm going to go over that in class. And we're going to move right to evaluating trig functions on the calculator. So you can use the calculator to evaluate trig functions of any angles measured in degrees as long as you are in degree mode. So on your calculator, to get into that mode, you need to click mode, you scroll down twice, and you make sure that degree is highlighted in black, not radian. So once it's highlighted in black, you can press second quit. And when you plug in these values into your calculator, you would put sine 27, and when you press enter, you should get 0.454. If you were in radian mode, you might get something different. So you want to make sure that you are in the correct mode. For the cosine of 100.4, we get negative 0.181. And for tangent of negative 40, we get negative 0.839. So make sure that you are in degree mode for this section. We will only be in degree mode. So if you want to just keep your calculator in that mode for this whole section, I would suggest doing that. So now there's some applications to solving right triangles. If you remember in geometry, we did a lot of word problems. So knowing what an angle of elevation versus depression is important. So the angle of elevation is the angle from the horizontal line of sight upward. So the horizontal line of sight is if you're looking straight ahead. So here, this dog, his horizontal line of sight would be right here. And then he is looking up at the bird. So this angle going from where he would be looking straight ahead to the bird, that is the angle of elevation. Now, on the other hand, the bird who's up here, his angle or his horizontal line of sight is right here, and the angle of depression looking down at the dog goes down this way. So it's always the angle from the horizontal line of sight to where they're looking, whether it be up or down. So this word problem says a surveyor is standing 115 feet from the base of the Washington Monument, as shown in figure 4.33. So that's this figure. The surveyor measures the angle of elevation to the top of the monument as 78.3 degrees. So they even gave us that angle right there. How tall is the Washington Monument? So now we're going to have to use our trig ratios to set up a ratio in order to solve this problem. So this is the angle. We're trying to find the side that is opposite that angle, and we are given the side that is adjacent. So we have O and A. So opposite and adjacent. So if you think of SOHCAHTOA, tangent goes with opposite and adjacent. So that is the trig function we would want to use. So tan, and you always put the angle next to the trig function. So tan of 78.3 is equal to the opposite side, which is y, over the adjacent side, which is 115. So now to solve this problem, I want to get y alone. Right now it's being divided by 115, so I need to multiply both sides by 115 to get y alone. So when I do that, so I get 4.829 for the tangent of 78.3, and then when I multiply 15 by that, this would be my final answer right here, 72.43 degree. Oh, not degrees. This would be 70.43 feet. Because we're not finding an angle, we are finding the height of this